Hey, AP Calculus students, Mr. Meunier back here again. Today is a big day, a good day for you guys. We're going to learn the shortcut to taking derivatives, and that's a good thing. Thus far, we've started Unit 2, and we've had a couple long lessons about what the derivative means, how the derivative lets us find the slope of the tangent line. So in essence, it's the slope at a single point. The derivative allows us to calculate the slope at one point, which is different because in algebra classes, you needed 2 points to find the rate of change or the slope. Now in calculus, we can find the slope at any individual point. And we went through the limit notation and the definitions of derivatives to find that. And it was a long process. Some of you probably already know the shortcut. And that's what we're going to unveil here today. So today is a good day. Today is like a holiday almost in a calculus class. So basic differentiation rules is what we're looking at. First thing, some symbolism ideas. This d over dx is take the derivative with respect to x. When you see something like this, that means take the derivative of whatever's inside that bracket. So this just kind of means take derivative or find the derivative. And again, this means find the derivative of x. Find derivative of x. This means find the derivative of any constant, of any number. And this is an important rule. The derivative of any individual number, like 3, 6, 11, 1.2, is always 0 because a constant does not change. And derivative means the slope. Slope means change. A constant number is unchanging. Hence, it has 0 derivative. It has 0 change. The derivative of just plain old x is 1, always 1. And then this is our big rule. Take the derivative of x to a power. To do that, the power multiplies to the front and you subtract 1 from it. It becomes n, the power, times the x, and then an n minus 1. But again, this symbol means take the derivative of x to the n power. So d dx means take the derivative, find the derivative of that piece. So how do we do these things? Well, if f of x equals x to the 5th power, directions say find the derivative of the following. This has a power. Power comes to the front. 5 comes to the front, and we subtract 1. This is going to be 5x subtract to the 4th power. Notation-wise, we would say this is f prime of x. F prime, the derivative of f is 5x to the 4th power. F prime of x. This derivative, again, it helps us find a slope. This, in essence, is a formula to find the slope at any value. This becomes a formula for the slope. So I'll write that down here. That's not a official, proper way, but this is really a formula for the slope, is what we've just calculated. Now here, g of x is the 4th root of x to the 3rd power. We do not want radicals for derivatives. We do not want radicals. We want to change to a rational exponent. So go back to pre-calculus or algebra 2 class and remember the 4th root of x to the 3rd power. This root is the denominator of a fraction exponent and the power is the numerator. So g of x is x to the 3/4 power. X to the 3/4 power. That's how we want to write it. Now I can take the derivative of that. So g prime of x is going to be 3/4 out in front. X, 3/4 minus 1 is negative 1/4. So g prime is 3/4 x to the negative 1/4 power. We tend to not want to have negative exponents. We can move a negative exponent and make it positive, if you remember back to pre-calculus, by putting it on the opposite side of the fraction. So right now, this is in the numerator. I can put it on the denominator. This becomes 3/4x to the 1/4 power. That's okay. Since it was in root form, you might want to turn it back into a root. That would be 3/4. The denominator is the root, the numerator is the power. 4th root of x to the 1st power. But I would say either of these I have in purple would be acceptable in most cases. C here, issue here, we do not want powers in the denominator. Move exponents to the numerator before you take these. And I can do that kind of like we did over on part B. I had the negative exponent, I put in the denominator. I don't want exponents in the denominator, whoops. So we can say y equals, there's a 1, and then x to the negative 3 power. 1x to the negative 3 power. Now I can take the derivative. So I'm going to say y prime. Negative 3 comes to the front, negative 3x, subtract, that becomes a negative 4. I tend to not want to have a negative exponent as part of my solution, so I can put it back where it came from. So y prime is a negative 3 over x to the positive 4. Okay. I'm going to add one right here, just because sometimes people miss this. If f of x equals a 3, going back to that definition above, that is a constant number. That means its derivative is going to be 0. The derivative of any constant is always 0. And, like it says up top, if f of x equals x, the derivative of that, derivative of plain old x, is always 1. 0 and 1. So again, these answers I have boxed. Those derivative answers, those become a formula to find the slope value. On these last two, they're numbers, so that tells us the slope is 0, and the slope is always 1. Okay. So, moving on here, if we have a constant multiple out in front, that's really not a big deal. We do what we've been doing here. So y equals 2x to the 7th. The 7 comes to the front, but now it multiplies with the 2. 7 and 2 become a 14. And then x, 7 take away 1 is 6. And this can be y prime is one way to write it. Another way you might see this is they'll put dy dx. It's the derivative of y based on the x's, dy dx, or y prime is fine. I'm just trying to show you other forms of notation. Here again, g of x, 3 over x squared. The x squared, again, we do not want exponents in our denominator. This needs to move up top. I'm going to call this g of x still, because I have not done a derivative, but 3, and then x, change the positive 2 to a negative 2. Again, these are rules from Algebra 2 and pre-calculus. This is still g of x. I've just changed how g of x appears. The second you start to move the power to the front and subtract from the power, that's when the derivative notation comes in. So g prime of x is negative 2 and 3 is a negative 6. X, negative 2 take away 1 is a negative 3. That's a derivative. This is a formula to find the slope. And from here, we tend to not like to leave negative powers, so I'm going to put that back on bottom. G prime of x, the constant of -6 stays, x -3 drops underneath and becomes x to the +3. And then last here, radicals are not great for derivatives. So again, f of x here, this would be the root is the denominator of a fraction exponent. The power is the numerator. This is x to the 5/6 power all over 8. We could think of this as a 1/8 x to the 5/6 power. So again, f of x equals 1/8 x to the 5/6 power. Now, 5/6 multiplies with 1/8. That's going to give us 5/48 x. 5/6 subtract 1 is -1/6. That's going to give us f prime. We tend to not want the negative power, so I'm going to put that in the denominator. 5/48 x to the 1/6 power. And then last, you could turn that back into a root. That's 5/48. That would be the 6th root of x. All right. Hopefully this is making some sense. The algebra manipulation is typically the most difficult part of these particular derivatives. All right, and again, on this last one, either of these two I haven't read are typically A-okay. I only went back into radical form since the problem began as a radical type of problem. Okay. Example 3 here, more of the same, I would say. 3x to the 4th over 8. Again, we could think of this as 3/8 x to the 4th power. If a power, a variable is in the numerator, you can kind of slide it off to the side. Something off to the side implies it's in the numerator. From here, I would say y prime. 4 times 3/8 is 12/8 x to the 3rd. Subtract from the 4. We can reduce 12/8 reduces down to 3/2. So y prime is 3/2 x to the 3rd. And again, this becomes a formula to find the slope. Here, we would like to deal with this power and this group before I start taking derivatives. So we can say y equals 3 to the 4th power is 81 x to the 4th over 8. Or y equals 81 over 8 x to the 4th. 4 times 81/8. 4 times 81/8. If this 4 comes out in front, the 4 and the 8 actually reduce down to a 1/2. So y prime is 81/2 x to the 3rd when I subtract. Again, if you need to see that, 4 times 81/8. When I bring the 4 to the front, 4 and 8 breaks down to a 1/2. 81/2 x to the 3rd. Again, y equals 9 over 7x squared. The x squared, we don't like that power to be in the denominator. So I'm going to rewrite this as y equals 9/7 x to the -2. I know I'm putting it out to the side, but being out to the side implies you're in the numerator. From here, -2 and the 9, -2 and 9/7 becomes, and again, this is going to become a y prime now. The moment I start to multiply the power to the front and subtract from that power, it becomes a y prime, is a negative 18/7. Subtract, and you get negative 3. I can put this negative power, we don't like to leave negative powers, back in the denominator. Negative 18 over 7x to the positive 30. And then last, just like B here, we would like to take care of the squared. This is going to be a 9 over 49. 7 squared is 49, x squared. I don't want the x squared to be in the, I don't want a power in my denominator, so I'm going to use my rules of exponents from previous courses, move that up, so it's 9/49 x to the negative 2. Negative 2 comes to the front. The second I start to move this out in front, it becomes a y prime, or another way of saying that is dy dx. I'm just going to change it up a little bit to show different notations. This is negative 18 over 49. Negative 2 take away 1 is x to the negative 3. And then again, last but not least, dy dx, or even y prime, we'll change, is going to be negative 18 over 49 x cubed. Sorry about that. Oops. All right, so that's those. And finally, example 4 to finish this up. We got multiple things. Typically, you want to take care of your algebra skills first. Take care of algebra skills first. So on A here, big issue. We got this big fraction. You got x on bottom. There's one denominator. We can split one denominator with all the numerator pieces. So I'm going to divvy this up and be x cubed over x minus 4x over x plus 5 over x. And we can look at each individual piece now. This works if you have one denominator. The single common denominator can split into multiple fractions, because you tend to do the opposite. You tend to get a common denominator, like I have written out in blue here. All of these have a common denominator of x, and you would combine them into one. You can also go the other way, and that's more beneficial for these derivatives. Again, I've not done any calculus. It's still f of x. It's going to be f of x one more time, because I'm going to reduce these. X cubed over x is x squared. 4x over x is 4. 5 over x does not reduce, but I do not want x in my denominator. That's x to the first power. I can put it in the numerator by making a negative 1. Now I'm going to start moving pieces. I do each one individually. This negative and positive sign separate them into separate problems in essence, separate derivative pieces. So f prime of x, the 2 comes to the front is a 2x. 2 take away 1 is 1, so 2x to the first. The derivative of a constant is 0. So plus or minus, I'll put a minus 0 to stay consistent with the problem, because that's a number. And then the negative 1 comes to the positive 5. That's a negative 5x, subtract negative 2. And that gives us f prime of x equals 2x minus 5. I don't want x negative 2. I can put x positive 2 underneath. In B here, I don't want these groups when doing derivatives. So let's FOIL this out before I do derivatives. If we do that, g of x is going to be x to the third minus 3x squared plus x minus 3. Now I have individual separate pieces. Nothing's grouped like above, and we can treat each one as individual derivative shortcut rules. So again, the 3 comes to the front. X, 3 take away 2 is 2. And this is now a g prime, because when I start moving my powers to the front and subtracting, that initiates the derivative. Subtract 2 and 3 is a 6. 2 take away 1 is 1. The derivative of plain old x, we said in the front page, is a 1. And the derivative of a plain old number is always 0. So g prime is 3x squared minus 6x plus 1. Here, that's not x cubed minus 27. That means x minus 3, x minus 3, x minus 3. We need to FOIL all these out. We can only do 2 at a time. So x minus 3 in front, if I FOIL out x minus 3, that's x squared minus 6x plus 9. Again, we can't do a derivative right now, not yet at least, of this big group. Then double distribute this. And again, this is still f of x. So that's going to be an x cubed. X and x squared is x cubed. X and minus 6x is minus 6x squared. X and 9 is plus 9x. Distribute the negative 3 in. So that's a minus 3x squared. Negative 3 and negative 6x is a positive 18x. Negative 3 and positive 9 is a negative 27. If I start putting, change my colors up. If I start putting like terms together, we have x cubed, negative 6x squared and negative 3x squared is negative 9x squared. Positive 9 and positive 18 is a positive 27x, and then minus 27. Now that everything's been FOILed, like terms have been combined, we can start to do our derivative. The second I start to move the power to the front and subtracting, this becomes an f prime. This will be a 3x squared, 3 to the front, 3 take away 1 is 2. 2 and minus 9 becomes a minus 18. 2 take away 1 is minus 18x. X plus 27x, again, 1 and 27 is a 27. Take 1 away from x, and that's a 0. So plus 27, x to the 0 is 27. And then the derivative of a constant is nothing. There we go. And then last, this one, radicals are no good. Square root. So that is a second root with a first power. Second root in a square root, square means 2. There's an x1 power. This is 2x squared minus 3x over x 1/2 power. We do not want this big fraction, but there's one denominator. We can separate this to 2x squared over x 1/2 minus 3x over x 1/2. If I bring this back down, g of x, if I reduce 2x squared, take away x 1/2. 2 take away a half gives us 2x to the 3/2 power minus 3x to the first, take away x to the 1/2. 1 take away 1/2 is 3x to the 1/2 power. All of this was pre-calc algebra 2 power rule manipulation. Now the derivative, 3/2 times 2. 3/2 times 2 is going to be 6/2, which is 3, x to the 1/2 power, minus 1/2 times 3 is 3/2, x. 1/2 take away 1 is a negative 1/2 power. If I clean this up a little, that's 3x to the 1/2 power. Make that a little bit better. Minus, we don't like to have a negative exponent, so I'm going to put that in the denominator. Minus 3 over 2, x 1/2 power. That's a pretty sufficient solution. Maybe they turn these back into square roots, I would say. I'll write that out. So g prime of x equals 3. 1/2 power means square root of x minus 3 over 2. 1/2 power square root of x. That could be written as well. All right, guys, hope you're doing well. Hope this made a little bit of sense. This is very powerful for us. We want to do derivatives in this form now, unless it specifically states to use the definition of a derivative. We want to run with this. And these, again, all of these answers I have boxed or circled. That's a derivative. That becomes a formula in the future to help us calculate slopes at one individual spot. Derivative means the rate of change. It's the slope occurring. All right. Hang in there. Bye.